In this video, we continue working on integrals that can be evaluated using trigonometric substitution. In part 1, we worked through example number A. Here we're going to start off with example number B. These were the rules on how to make substitution that we established in part 1. Okay, so in part B we have got the integral of dx over x squared times the square root of 9 plus x squared. From this we said if the quadratic form involves a plus, the substitution is x equals to tangent theta. Now so here, just call this I. We have got 9 plus x squared. That is the same as 3x squared. Sorry, 3 squared plus x squared, which means our A is going to be 3. So we're going to let x to be equal to 3 tangent theta. Then dx is going to be 3 times the derivative of tangent, which is secant squared d theta. X squared is going to be 3 tangent theta all squared, so it's going to be 9 tangent theta squared. Then our integral is going to look as follows. In the numerator, dx is 3 secant squared theta d theta. In the denominator we have got x squared, so that is 9 times tangent squared theta. Then in the square root we have got 9 plus x squared, which is 9 tangent squared theta. Alright, then the 3 over 9, which is this 3 and this 9, we can take outside the integral sign as 1/3. So we still have this in the numerator, tangent squared theta. Then in the square root, if we factor out 9, this is going to be 1 plus tangent squared theta. Then of course we know that 1 plus tangent squared theta is secant squared theta. So we're going to have 1/3 secant squared theta d theta in the numerator, tangent squared theta. So this is going to be the square root of 9 secant squared theta. Then at this point we can evaluate the square root. So we know that square root of 9 is 3, and square root of secant squared is secant. So we're going to just have here 3 secant theta. Okay, then the 3 we can take outside the integral. The secant terms are going to cancel out, so this will cancel out with that. So we're just going to have secant in the numerator. So this is going to be secant theta d theta all over tangent squared. Now this is going to be a bit of a problem if we try to integrate it in terms of tangents and secants. However, if we write it in terms of sines and cosines, then all of a sudden we find that we're going to have breakthroughs. Okay, so if we write the tangent squared in terms of sine and cosine, we're going to have sine squared here and cosine squared here. Secant is cosine in the denominator. Okay, so this is going to cancel out. So this is just going to be cosine over sine squared. And so at that point we could use substitution, because the derivative of sine is cosine. Okay, however, we're going to show you that perhaps we can write this as a standard, a term that is a standard integral. Well, you can write this actually as cosine over sine is cot, and then the 1 over sine is cosecant. This is a standard integral. Derivative of cosecant is negative cosecant cotangent. So that means integral of cosecant cotangent is simply negative cosecant. Okay, so the integration is done. Maybe just to assist, to help us when it comes to rewriting this in terms of x, this is actually 1 over sine. So now, as we did in part A, which was done in the part 1 integral, to write this in terms of x, we go to our original substitution. We've got x equals to 3 tangent theta. So if make tangent theta the subject of the formula, then tangent theta is x over 3. So that means our right angled triangle, if this is theta, tangent is opposite over adjacent, then the hypotenuse here is going to be x squared plus 9. We said a general guideline is when you do this, one of the sides should have a quadratic expression similar to the quadratic expression we had in the starting integral. This, we've got 9 plus x squared, and we have got the same thing there. All right, so here we just need sine in our integral. So from this right angled triangle, sine is going to be the opposite of adjacent, so the opposite of a hypotenuse. So that's going to be x over square root x squared plus 9. However, here we have got we need the reciprocal of that. So that tells us that our integral, which is minus 1 over 9 sine theta plus c, is going to be minus, so the square root is going to be in the numerator now, x squared plus 9 all over 9x plus c. So that is going to be our final expression. Of course, you could differentiate this and prove that it is going to work out to this. So that is part B. We're now going to go to part C. So in part C, we have got the integral of dx divided by the square root of 4x squared minus 9. Dx divided by the square root of 4x squared minus 9. We have got a slight issue here with this one. Issue being the fact that the x squared has got a coefficient of 4, and yet in the guideline that we have, the x squared is always having a coefficient of unity. It may be positive like it is here and here, or negative, but it should be unity. Then from there we can work out a squared. So we need to manipulate this algebraically so that the coefficient of x squared is unity. So we're going to do that by factorizing the 4. So if we factor out 4, then this is x squared, but this is now going to be 9 over 4. Okay. And then if we do the square root of 4, so then this is going to be the integral of dx. Square root of 4 is 2. So this is simply going to be x squared minus 9 over 4. Now this is in a form which is corresponding to the standard forms of the expressions we are using. So of course this we can write as 3 over 2 squared. So that means our a is going to be 3 over 2. The x squared is positive here, so that means it's the other case. It's the case of secant. So we're going to let x be 3/2 secant theta. Derivative of secant is secant tangent. So that means dx is going to be 3/2 secant theta tangent theta d theta. Then we can rewrite this integral. So I is going to be, so remember, got that 1/2. dx is 3/2 secant theta tangent theta d theta. Then so maybe we can do x squared here. Squared is going to be 9 over 4 secant squared here. So this we're going to plug in here. So that is going to be the square root of 9 over 4 secant squared theta minus 9 over 4. Okay. The 3/2 times 1/2 is going to be 3 over 4. So that's this 3/2, this 3/2 here. Then so we're going to have secant theta tangent theta d theta. Then if we factor out 9 over 4 here, it's going to be secant squared theta minus 1. Okay. Then we can take this out of the square root by evaluating square root 9 over 4, which is just going to be 3 over 2. But since it's in the denominator, if we bring it here, it's going to be 2 over 3. Secant theta tangent theta d theta. So, and then secant squared minus 1 is tangent squared theta. So that means the denominator is simply tangent because it got square root of tangent squared. This is going to work out to 1/2 the constants. So secant theta tangent theta d theta all divided by tangent theta, and then tangent theta we can cancel out. So this is simply the integral of secant, which again is a standard integral and we said that is the ln of magnitude of secant theta plus tangent theta. So that is the value of the integral in terms of theta. So we need to convert it and write it in terms of x. So again, we go to the starting or the formula that we used to write everything in terms of theta. So from there we have got secant x is 3/2 secant theta, x is 3/2 secant theta. Remember, secant is 1 over cosine, so this thing is telling us that cosine theta is 3/2x. Then if we have our right angled triangle here, cosine is adjacent over hypotenuse, so that means the opposite is going to be 2x squared, which is 4x minus 9. Do we have a quadratic expression like this in our original integral? 4x squared minus 9, the answer is yes. So things are looking okay. We need secant here, which we can have from here. So if we just make secant theta subject of the formula there, it's going to be 2x/3. We need tangent, so tangent theta is opposite over adjacent. Okay, so it's just going to be these two. So that means so therefore I, which is 1/2 ln secant theta plus tangent theta, magnitude of that, is going to be equal to 1/2 ln, we have got 2x/3 plus square root 4x squared minus 9 all over 3 plus c. Can write this as one fraction, so it's going to be 2x plus square root 4x squared minus 9 all over 3 plus c. By properties of logs, we can write this as ln of 2x plus 4x squared minus 9 minus it's going to be minus 1/2 ln 3, then plus c. However, 1/2 ln 3 is a constant, so if we make this whole thing into k, then we can write this as simply 1/2 ln 2x plus square root of 4x squared minus 9, and then plus some other constant k, and that is going to be our final expression. Okay, we're going to bring this video to an end now. We're going to continue with the other problems in part 3 of this series. Thank you for watching. Please do not forget, of course, to press the subscribe button. If you've got any questions, you can post them in the comments section.